Good morning, students. This is Dr. Sushree Samikhya Pattanaik. Today, I welcome you all for the class, and we are going to discuss regarding AC circuit. So, these are our outlines: analysis of AC circuit with a pure resistance, analysis of AC circuit with a pure inductance, and analysis of AC circuit with a pure capacitance, and we will do some numerical on the above analysis. So first of all, we will discuss AC circuit with a pure resistance. So before going for analysis, let me tell you, in our electrical engineering, we are dealing with three passive elements, that are resistance, inductance and capacitance. So we know that passive element means it doesn't have any source of EMF. So it will depend on others. So here there are two types of passive elements are there. One is our pure, which is also known as ideal, and second one is practical. Pure means it is loss free. It doesn't consider any internal resistance values, but in case of practical, it considers the internal resistance, so it has some losses. So here we are taking a circuit by taking one resistor, and we will apply a AC voltage. From the symbol we can find that this is a AC source, so we can write the instantaneous value of voltage V will be equal to Vm sin omega t. So here the circuit is closed. From the voltage source we will get our current which is passing through the resistor. We can see that there are no other resistance or elements which is connected series and parallel. That's why whatever supply voltage, it will appear across only resistor values. So here we can write the instantaneous value of voltage V, which will be equal to Vm sin omega t. So in order to calculate current value, we will apply our Ohm's law. Ohm's law means whatever variation in voltage in resistor, same amount of variation will occur in case of our current. So we can apply one formula, that is I is equal to V by R. So here we can write V value in terms of AC. So we will write Vm sin omega t by R. Now if we will take Vm by R, we can also write Im, means Im is equal to Vm by R. So here I can be written as Im sin omega t. So previously we got V is equal to Vm sin omega t. Now we got I is equal to Im sin omega t. So here we will do the analysis by taking two diagrams. What are they? One is waveform diagram, another is our phasor diagrams. Waveform diagram means in x axis we are taking the time period and y axis we are taking the magnitude. So here in y axis we will represent both voltage as well as the current values. So here as it is a sinusoidal waveform, it will be started from 0, then the voltage value will be peak at pi by 2, again it is reduced to 0 at pi, then it is coming to negative peak at 3 pi by 2, again it is coming to 2 pi. So here as it possesses Ohm's law, the variation will be linearly. So current value is also started from 0 and it is peak at pi by 2, it is 0 again pi, then negative peak at 3 pi by 2 and again it is 2 pi. We can see that from the waveform there is no angle variation between voltage and current. Now we will present our voltage and current by through the phasor diagram. Phasor diagram means this is the physical representation of voltage and current with respect to its corresponding angle. So we can see that the angle variation is 0. So we can take the reference as voltage, then current will be in same phase, or it is called as in phase. No angle variation of voltage as well as current. Now on the basics of this analysis, we are going to solve one problem. So we are taking a AC circuit, consists of pure resistance and its value is 10 ohm and it is connected to a supply of 230 volt 50 hertz. We have to calculate current, power, and we will write the equation for voltage as well as the current values. So before going for the problems, always students remember you have to see in the problem what are the given data. So this 10 ohm means this is the resistor value, and this 230 volt is your RMS value of voltage. Don't take it as maximum value, and this one is your frequency. Now what is our next step? We have to calculate our current value. So how to calculate? By applying the Ohm's law. So I is equal to V by R. So previously all values are with us. We will put 230 by 10. So we are getting 23 ampere. Now we will get the power. Power means it is the product of voltage and current. Also by applying the Ohm's law, we can have another formula, that is our V square by R. Another is our I square into R value. So here only we are taking P is equal to V into I. So we will multiply 230 into 23, that is our 5290, means 5290 watt. Now we have to calculate the maximum value of voltage as well as maximum value of current. How to get? We know that RMS value will be equal to maximum value by root 2. So here how to calculate our Vmax? Just multiply root 2 into V. Then only we will get our value of Vm. So here V value is 230 volt. Previously I said, then root 2 will be multiplied. Then we are getting our value 325.27 volt. Next one, same procedure we will follow for Im calculation. That is our root 2 into I. So I we have already calculated 23, then it is multiplied with root 2. So we are getting 32.52. So we know that the voltage equation is equal to V. V is your instantaneous voltage, that will be equal to Vm sin omega t. So here V, we can write V is equal to Vm sin omega t. So what is our omega? Omega means, always remember, this is our angular frequency, and that value will be equal to what? 2 pi f, and it will be represented by radian per second. So here it is written omega, which will be equal to 2 pi f, which will be equal to 314 radian per second, by putting f is equal to 50. Next we will write the equation V is equal to Vm sin omega t. Already we have calculated V value. Then I is equal to Im sin omega t. I is calculated 32.52 sin 314 t. Next we will discuss AC circuit with a pure inductance. So same as here, pure means always it is loss free. Whatever internal resistance of the inductor, we are not going to consider it. So this is a AC circuit. In replace of resistor, we are taking an inductor. Same AC voltage we are applying. So here instantaneous value of voltage V will be equal to Vm sin omega t. Circuit is closed. I is equal to we will get our current from our voltage. Here only inductor is present. So supply voltage will appear directly across the inductor value. So here we can write V is equal to Vm sin omega t. Now in order to calculate the current value across your inductor, we will find by through this procedure. So here the voltage across inductor can be calculated by your formula V is equal to L di by dt. So in replace of V, as it is a sinusoidal waveform, we can write Vm sin omega t. So here by putting left hand values of V, our equation will become Vm sin omega t, which will be equal to L di by dt. Now what we will do, we will take all L and dt to the left hand side, then we will calculate the di value. So by multiplying, cross multiplying, we can get di is equal to Vl by L sin omega t dt. So again by taking integration in both the sides, we can get our equation of I, which will be equal to Vm by L sin omega t dt integration. So actually Vm by L will be within the integration, as it is constant we have taken it outside. Now after taking integration of sin omega t dt, our equation will be what? It will be Vm omega L multiplied with minus cos omega t, because here sin omega t means integration will be minus cos omega t, again omega will be divided. So our equation I will be equal to Vm by omega L, again it will be represented in terms of sin, so we can write sin omega t minus pi by 2. Why? Because minus cos omega t can be represented as sin omega t minus pi by 2. Now previously we got the voltage value V is equal to Vm sin omega t. Now we got I will be equal to Im sin omega t minus pi by 2. So these are two equations. We can see that here only sin omega t is there, but here we are getting sin omega t minus pi by 2. The angle difference is minus 90 degree. So here in the place of we have written Vm by omega L, where it will be equal to Im. Now as I have already told you in previous slide that there will be the angle difference of 90 degree. V is represented by Vm sin omega t, but current is represented by Im sin omega t minus 90 degree. Always remember, in previous classes I have already explained regarding leading and lagging. Minus means always remember that is your lagging place. So here by the waveform also we will see the variation between voltage and current. We can see that the voltage is a sinusoidal waveform. It will be started from 0, but the current will be started after minus 90 degree. So here we can see that voltage is started at 0, but the current is started at 90 degree. So here after that we can see that variation of current waveform. The angle difference is 0 here, and this point is pi by 2. So we can get our 90 degree value. So this is the waveform for a pure inductor value. Now it is represented by the phasor diagrams. So we are taking the reference as voltage and current value. We can see that 90 degree clockwise direction. So this is the phasor diagram for our pure inductor. So another terms we will get from this analysis, what is inductive reactance. Always remember the inductive reactance XL can be represented by 2 pi FL, or it will be termed as omega L. So here we can get our Im value Vm by XL. Always remember the unit of inductance is same as the resistance. It will be ohm. So depending upon this analysis, we are going to discuss one more problem. So here we are taking a pure inductive coil which allow a current of 10 ampere from a 230 volt 50 hertz supply, and we are getting our values of inductance of the coil. Then we will calculate the value of power absorbed. Then same thing, we are going to write the equation of voltage and current for the pure inductor. So as I have said, so we have to first find the data which is given in the problem. So what is that? So pure inductive coil allows a current of 10 ampere